All right, good evening, everybody. This is Mike Murphy from the National Weather Service in Binghamton here. Thank you for joining us for the winter weather Skywarn. We'll wait another minute or so for some more people to log in and join us. I just want to do a quick sound test and video test. Make sure you guys can all hear and see me and see my screen. Let me unmute everybody real quick and just let me know if you can hear me okay. Okay, I see somebody chatted, Joshua, saying that they could hear me.
Hello.
Yeah, hello.
Sounds good. Sounds good.
Okay, awesome. Thank you. Just wanted to make sure before we got started that everybody could hear me okay. So, okay, I will put everybody back on mute for now then, and we'll have time to go with the presentation where we can open up for any questions. You can always type a question in the chat section there if you want to do it that way as well. All right, we'll wait another maybe 30 seconds and then we'll get started. All right, so again, this is Mike Murphy with the National Weather Service in Binghamton. Thank you so much for joining us for the winter Skywarn tonight. Like I said, I think we'll leave everybody on mute for now so we don't have any background noise. But if you have a question, just feel free to type it in the chat room. I think there might be like a raising hand button. Let's see. Do we have that? I'm not sure if we have that, but definitely either chat it or I guess that'd be the best way. And then I'll try to stop maybe halfway through. We'll take a short break and do some questions at that point, and then definitely leave time for questions at the end as well. Let's see. Okay, so I think I guess let me. Okay, let's see. There's a question here. Still a little new to this GoToWebinar format. See, there's a question. So let me see. Bigger. Somebody asked, is the chat visible to everyone? I guess I'm not sure. I think it probably is. See, I think the questions are maybe only visible to me, but the chat would be visible to everybody. So, okay. I guess at this point, everybody just let me know if you're having any audio or visual difficulties. I think people said it's okay. So if not, just let me know. But otherwise, we'll go ahead and get started. Okay, so again, this is the winter Skywarn for the winter Skywarn training for the 2020-21 winter season here. And again, thank you for joining us. My name is Michael Murphy with the National Weather Service here in Binghamton. And yeah, we've been kind of busy tonight. We have some winter weather out there already. So this will be good timing to get this training done so that you guys will have a better idea of winter weather in the area and how you can help us out at the weather service here. So thank you for being on this call and or on this presentation, and thank you for volunteering to be a Skywarn spotter. So all right, we'll get started. So just real quick, the agenda. We're just going to go through a quick overview of the National Weather Service, why we need you guys to be our spotters, why we appreciate it. Obviously, we're going to go through different types of winter weather that we see here in central New York and northeastern Pennsylvania. We'll then go into how we forecast a winter storm, all the different components here at the National Weather Service. We might take a short break if everybody wants to, or we could just possibly go right through it here, but we'll see if we have questions. Then we'll go into number 4, National Weather Service products, what we put out there as part of our forecast package. Number 5, we'll look at how to properly measure snow and ice, do a wrap up, and then the final thing is we'll take a look at the winter outlook and what we could expect coming up for this winter. So just a quick background on the National Weather Service and structure. Let's see. Okay, so we are under the Department of Commerce, and then we have NOAA, National Oceanic Atmospheric Administration. Then we have the National Weather Service. So if you're curious, we are under the Department of Commerce here. So our office is located near the Binghamton Airport, and we are open for operations 24/7 every day of the year. So we're always here, always staffed. And our area of responsibility for forecasting and warnings it's a pretty big area. It extends all the way from Oneida County, Utica, Boonville in the north, Syracuse, all the way out to Corning, Steuben County in the west, all the way over to the Catskills, Oneonta and Delhi, Monticello in the east, and then all the way down into northeastern Pennsylvania, including Scranton, Wilkes-Barre, Honesdale, that whole area. So we actually have about 2.5 million people that live within our county warning area of responsibility. Now here's our office as a part of the National Weather Service right here in Binghamton. We can see we have about 121 weather forecast offices spread throughout the entire United States, including Alaska, Hawaii, and Guam too. So we're spread pretty evenly across the U.S. We also have other operations centers as part of the National Weather Service, including river forecast centers, which is in State College and near Boston, Massachusetts. And we have other river forecasting centers throughout the country as well. And we also have like our regional headquarters and national headquarters also. So just gives you an idea of where we are in the entire United States. So moving into more winter weather here. As a National Weather Service, we are responsible for alerting the public of any hazardous weather, severe weather. So we obviously issue warnings, watches, warnings, and advisories for any severe convective weather like thunderstorms, tornadoes, floods, blizzards, ice storms, high wind events, hurricanes, and other coastal storms as well. So we really have many different types of warnings that we can issue for the public. So what is the Skywarn program, you may be asking? Well, it's just a national volunteer program that's run by us at the Weather Service. Our goal is to provide the Weather Service, us, with ground truth reports of significant weather that might be happening. So just keep that in mind as you go through the presentation. Because we are, as you saw, the offices are pretty evenly spaced, but we're right here in Binghamton, but that doesn't mean we know what's going on necessarily on the ground as far as weather in some of the more outlying areas away from the office. So you guys are kind of our boots on the ground. You give us those ground truth reports. So we appreciate that. And it really helps our forecast and warning process. So again, just hitting on these points a little bit more here. Our Skywarn spotters really help us out. We appreciate the volunteers. They assist us with real-time reports that help us to make better warning decisions. They help forecasters gauge just how much snow is falling, how bad it's getting out there. Your information could definitely be used to provide credibility to our warnings that are issued. or help us to issue a new warning if you report to us that conditions are really going downhill, you're getting heavy snow, heavy icing, we might use that to help to issue another warning for the public. So very useful having those ground truth reports. Yeah, I mean, your information you provide us after you've been trained can definitely be potentially life-saving for other members of the community. So really important. Yeah, so the bottom bullet there, the trained eye of the storm spotter is definitely still one of our greatest assets. And we'll talk more about that in the presentation. We do have tools that obviously help us to see the weather conditions across the area, including radar, surface observations, but they just cannot cover everywhere. So we'll talk about that coming up and just how important you guys are. So yeah, you can see the blue dots represent on this map where we have observations from local ASOS weather observation systems, which are generally located near airports most of the time. So in our area, we have pretty good network here. We have a station in Rome, Syracuse, Cortland, Ithaca, the Elmira Corning Airport near Corning, which would be here at Binghamton, Sydney, Towanda, and the Scranton Wilkes-Barre Airport. But it's spread out in between these observations. We may not necessarily know how bad the weather is until we get reports from our Skywarn spotters. So, and it's important to note that only a few of these sites, very few, measure snowfall. So it's really critical that we get those snowfall reports from you guys. So the red dots on this map represent our most recently trained weather spotters, which after tonight will include you guys. So you can see that we have a lot more coverage when we include our spotters. They really help us to fill the gaps, and they help us understand exactly what's happening as far as winter weather and all types of weather in our area. And as many of you probably know, central New York, northeastern Pennsylvania, we have extremely variable weather due to terrain and other mesoscale and microscale processes. So including lake effect, even just like in the summertime, thunderstorms can hit very localized areas. So it's important that we have as much coverage as possible to fill in these gaps. So that was kind of the introduction here, and now we're going to move on and talk more about some specific winter weather hazards that can definitely impact our area. So let's see. So real quick, what exactly makes a winter storm? Well, you need certain ingredients to come together. We all probably know this. You're not going to get heavy snow in July, hopefully not, because you're lacking the cold air. So in July, you have the moisture and lift. So you can get rain and thunderstorms, but you don't have that cold air. So you really need all these three ingredients to come together. If it's just cold and dry, you're missing the moisture, you're really not going to see significant snow. And you also need atmospheric lift. So you can see in the animation here with the red arrow, you need that air to rise and condense to form clouds and precipitation. So that's why sometimes in the winter we have very cold conditions. A cold Canadian high pressure can come down, but that's going to do the opposite of lift. It's going to be pushing down in the atmosphere. And that's why if you have dry high pressure overhead, you might not see any snow. It could be very cold still. Our area is kind of special because we do often get, even in rather dry air masses, when you have the cold air and the lift, it can pick up lake effect moisture and produce its own snowfall. So we'll talk more about that coming up. So just real quick, some sources of the cold air that we get in our area, excuse me. So oftentimes we can see Arctic cold fronts coming through. So it just drops down right out of, really they originate up north of Alaska and sweep all the way through Canada right into our area. You can also get, like I mentioned, the cold Canadian high pressure systems can supply cold air as well. So those are kind of our two main sources, but really, I mean, when it comes down to it, in the winter, if you have a a northerly or northwest wind that's more than likely going to be bringing down cold air from Canada, and the Canadian cold air originates from the Arctic, so it just comes right down out of the north into our area. And then as far as moisture sources, we definitely have plenty of moisture sources in our area. So we can get moisture right out of the Gulf of Mexico, or you can get it coming off the Atlantic Ocean. So yeah, if we have the coastal systems, nor'easters, as they move up along the coast, again, they can draw moisture from the Gulf of Mexico, then the Atlantic Ocean into our area. And then also, as I mentioned before, we can certainly see those cold air outbreaks and coming over the Great Lakes. That can bring lake effect moisture up here as well. Just keep that in mind. And then the third ingredient is you need a source of lift. So you can have several different ways this happens. You can get lift along a warm front, lift along a cold front. Let's see. Temperature differences over the water, like lake effect, and in our area, the different mountains and terrain can also, as you can see in the bottom picture, can also induce some atmospheric lift and help to create precipitation. So again, there's definitely several different ways you can get that lift, and then if you can just get all the three ingredients to combine together, that's how you're going to get your winter weather events and winter storms. Okay, hang on. Somebody has a question here. Let me unmute everybody. Somebody said all they can see is me. Gonna unmute everybody. Can you guys see my screen as well? That's very important, obviously. Can you see the PowerPoint presentation?
Yes.
Yes, okay.
Yeah. Yep, we can see it.
Okay, very good. Somebody, looks like Brad was having an issue. Hopefully he's okay now. Okay, it sounds like most people can see my screen.
I think maybe he was expecting to see like a video conference.
Okay. Okay, so I think we're okay. We'll continue then. I'll just leave everybody off mute. It sounds like right now it sounds like there's no background noise. So if you guys have any questions, just chime in. You can just unmute yourselves and chime in. So. Okay, sorry about that. We'll get back on track here. So yeah, one of our most important winter storms to watch out for is going to be the nor'easter. I'm sure many of you have heard of the nor'easter before, but if not, it's actually named for the direction that the wind blows from the storm. So as the storm moves off the coast, out ahead of it, we definitely get the northeast winds coming into our area. That's where the name comes from. But really all you need to know is that this is a storm system moving up. Usually either originates from the Gulf of Mexico or just along the Atlantic coast there, like North Carolina, that area. Moves along the eastern seaboard, and it could be an intense low pressure system. That's how we oftentimes get our heaviest snowfall in the area, at least the most widespread heaviest snowfall. And you want the storm, in order to get heavy snow, you want the storm system to pass to your east, south or east. So we'd be on the left side of the storm, and that's where all the ingredients come together. You have the cold air, the moisture, and the lift on that side of the storm, on the western side of the storm, and that's where you get the heavy snow. So, you can see in the diagram here that, as we talked about, the cold air source is oftentimes that cold Canadian high pressure to our north. That's where you want to see that if you're looking at the weather maps. And then again, you want to see the low pressure passing. Usually a good track for our area would be if the low passes right near Washington, D.C., and then pretty much right over New York City. So if it kind of just hugs the coastline, that's where we'll get our heaviest snow, back in central New York and northeastern Pennsylvania. So let's see. Yeah, we kind of already talked about this. They are named for the northeasterly wind that gets into our area out ahead of the storm. And really just the takeaway is, think of a strong low pressure system moving along the coast, with the heaviest snow being on the western side of the storm. And the satellite loop is just an example of a nor'easter, actually this was back in mid-April, April 16, 2007. So sometimes nor'easter can even bring heavy snow to our area, even into the late winter and early spring months as well. So this was a pretty good storm for our area. All right. So yeah, many of our historic snowstorms can be classified as nor'easters. Let's see, just some examples. You know, we had the blizzard of 1993, which, yeah, that's the image picture here, the satellite image in the middle of the page here. That's the blizzard of 93. We had the blizzard of 1996. And then we had March 2017, just a few years ago, we had a very significant nor'easter that produced 2 to 3 feet of snow, even more in parts of the area. So, you know, not every nor'easter is going to be historic, but they generally bring our most steadiest snowfall, and a few of them can be very strong and produce historic snowfall. So, any questions on nor'easters before we move on? Okay. Oh yeah, so this was an example of the storm I was talking about, March 14th, 15th, 2017. This was an unusually intense nor'easter that brought between 3 to 5 inch per hour snowfall rates to parts of the area. We had almost 36 inches of snow here at the Binghamton airport. We had 32.4 inches in just one day. That was a new record. Utica had 36 inches of snow. Even Scranton Wilkes-Barre had about 22 inches of snow. And yeah, this was just one incredible storm, and historic. That's the only way to describe it. And yeah, we'll see one of these big nor'easters every couple of years for sure. So if history tells us anything, is that we can certainly see some heavy snow in our area. And these are the systems that do it. So if you're reading our forecast discussions or watching the news or media and they're talking about nor'easters coming our way, it's kind of a keyword to know that we could be seeing some heavy snow. So we may be needing your spotter services. Oops. So I'll just show you guys a satellite loop of this blizzard of 2017 real quick here. So the storm, this one actually developed down here, like near the Florida Panhandle. Then it moved up along the coast, kind of along the eastern banks of North Carolina. And then it moved up, like we mentioned, basically right over New York City. And we were right on the western side of the storm, just in the perfect spot to get that heavy snow for a long period of time. So, and we had lake effect snow actually developed after it too. So it was quite a storm. I'm sure many of you remember it. And you know, we might see another storm like this. Who knows? This winter, never know. Okay, so then this is a more detailed view of, again, the March 2017 blizzard or nor'easter that we had. And this shows the location of the low pressure systems in the fronts, and we have the radar imposed in the background. So again, you really want to look for the low pressure moved right over eastern North Carolina, right here, the main low. And then we'll see the heavy snow moved in here. This is about 1 a.m. on the 14th, so overnight of March 2017, the heavy snow moved in. the low pressure track right along the coast, just east of Washington, D.C. We were getting heavy snow still by sunrise on the 14th. And the low moved almost due north, again, right pretty close to New York City, maybe just a little east, and that's a very favorable track to just keep the heavy snow bands right over our area. And then we saw the lake effect snow behind that. So here's a closer view of the radar from this storm. So here comes the snow, it's like moderate, and then you see those yellows and dark greens coming in. That's very heavy snow, 2 to 4 inch per hour type snow rates. See another band developed right over Binghamton, another band. They were kind of rotating in from the east with these nor'easters. And then it kind of pivoted around to stay right over our area all day through the 14th into the evening hours. Then the wind started to switch to the northwest, and we started to get lake effect bands developing. This was all the way into the next, this was like 24 hours later, still snowing. And it just really transitioned to lake effect. So yeah, this was a pretty intense storm. Let's see. Oops. Yeah, so here's the, using all of our data resources, including our Skywarn spotters, we were able to collect the storm total snowfall data from March 14th through the 16th, 2017. And yeah, you can see it was pretty crazy, pretty intense snowfall over much of our forecast area, with the heaviest band being 2 to 3 feet, even getting close to 4 feet from basically right along I-81 and points east from Scranton to Binghamton, over into Shenango, Madison, Oneida, Otsego, Delaware counties. That was just some of the heaviest snowfall in that area. Back to the west, they were kind of on the edge of the storm a little bit more, so looks like Steuben County only got like 8 to 12 inches of snow. So the real historic snow was mostly from I-81 points east, looks like. So this was just a good example to go through and just, share with you guys a little insight on what we look for in nor'easters and what can potentially happen. So during this event, I was not at this office yet during this event, but I'm sure that our Skywarn spotters were very useful in helping us to keep situational awareness on what was going on out there throughout this long-lasting major blizzard. So okay, so moving on from the nor'easters and blizzards, which are definitely some of our major storms we see around here, we can also get snowfall in different ways. We get what's called Alberta clippers, or just clippers, we call them sometimes, but they generally originate over the western Canadian provinces, usually like Alberta, that area. They're usually fast movement, they don't have a lot of moisture, they kind of track across the north central United States and don't really pull too much moisture from the Gulf of Mexico or Atlantic Ocean. So they often produce a quick burst of light to moderate snow with colder weather behind it. The heaviest snow will still fall just to the north of the storm track. So we get these many times throughout the winter here. And again, those will be your kind of low end snow producers, 1 to 3 inches, maybe a little more locally, but generally pretty light snowfall. But behind the Alberta clippers, that's where you can see when we get those cold westerly or northwest winds behind it, we'll get lake effect snow developing. And how lake effect works is you want to have cold air going over the relatively warmer waters of the lakes, and this will produce rising air as it moves inland, and it just produces a lot of snow in generally narrow bands. So here's an example of lake effect on a northwesterly wind flow coming off Lake Ontario and the Finger Lakes, right down into central New York, and even parts of the northern tier of Pennsylvania. So you can see this is the average annual snowfall across our area. I wanted to show you guys this so you can see that we have actually very variable amounts of snow throughout the year, even just within our forecast area. So the lake effect, which is indicated by the arrows here, this can definitely increase the average annual snowfall parts of the area. So on a westerly wind, you'll see the heavy lake effect snow impacting like north of the New York Thruway, basically. And the heaviest snow in the whole region really falls right over the Tug Hill Plateau, which includes the far northern tip of our county warning area across far northern Oneida County. And it's like they average 150 to 200 inches of snow per year up there, places just north of Camden, over towards Boonville, Woodgate, that area. And even further north on the Tug Hill Plateau, they average over 200 inches of snow per year, mainly due to lake effect. And then this other area of enhanced snowfall is because we get the northwesterly winds sometimes, and that brings lake effect down into Syracuse, Cortland County, down into Shenango County, Otsego, southern Oneida County, Cayuga County. So that whole area can get enhanced snowfall from lake effect if we have northwest winds. And it's also higher elevations there, so they get that upslope lifting effect we talked about. So this area down here, they average between 75 to 100 inches of snow, except for even a little higher up towards Tully and close to Syracuse and Cazenovia. They're more 125 to 150 inches of snow per year. So those are kind of our two snow belts within our forecast area. Basically just the northern part of the area. Excuse me. But then heading down to the south, down to the southern tier, we still get some lighter lake effect snow at times and lake effect flurries down here. But most of our snow will come from those Alberta clippers and the coastal storms over here. So we're looking at 50 to 75 inches for the most part, with a little higher for the higher terrain of the Catskills. And then there's actually a little bit of an area that just usually sees less snowfall out towards the Chemung River Valley, near Elmira, Corning. That area actually only averages about 40 to 50 inches of snow per year, because they oftentimes are on the edge of those coastal systems, and they just don't get a lot of lake effect snow over there either. So yeah, that's just kind of a look at our hot spots for snow and areas that usually see less. And same thing down in the Wyoming Valley region, in Scranton to Wilkes-Barre, they're kind of on the lower end, being lower elevations and not seeing really any lake effect snow most of the time. So they average between 30 to 50 inches as well. Okay, before we move on to ice storms, do we have any questions on lake effect snow? Okay, I don't see any questions at this time, so okay, we'll move on then. So moving on, like I said, to ice storms here. This is another winter weather hazard that we have in our area. The setup for an ice storm is similar to a snowstorm, but just a little different in some areas. We still like to see that cold Canadian high pressure to the north that kind of supplies that northerly flow of cold air into the system. But oftentimes for an ice storm, you'll see the low pressure itself moving either directly over the area, if not to the west, across maybe western New York. And when you see that, you can see in the diagram that these arrows indicate that you get warmer air kind of surging up from the south on top of this cold, dense air that kind of stays locked in place at the surface with the high pressure to the north. So you get overrunning. Precipitation could start off as snow, but the warm air aloft comes in. It could be anywhere from 1,000 feet to 5,000 feet above the ground level. You get this warm layer aloft coming in, and that melts the snowflakes as it goes through, and you get raindrops that freeze on surfaces that are below freezing still near the ground level. So it can take a long time from the warm air to make it down to the surface. So especially in parts of the area, and that's where you get those ice storms. So let's see. Yeah, so this just kind of gives a better example of what I was talking about in the previous slide. So if you have the cold layer aloft and at the surface and in the mid-levels, which is indicated on the left panel here that says snow, you'll see the snowflake will just fall right through the cold air, doesn't melt at all, and you get snow on the ground. Sleet is when you have the snowflake, there's a mid-level warm layer above 32 degrees, above freezing. So the snowflake melts as it goes through that layer, but then there's a fairly thick sub-freezing layer below that warm air. Could be 2, 3, 4,000 feet thick of sub-freezing air. So as the water droplet goes through that, it refreezes into a tiny little ice pellet called sleet. So you get the sleet pellets hitting the ground. And then freezing rain, which can be one of the most dangerous precipitation types in the winter. That occurs when the snowflake melts through a larger warm layer. There's only a very shallow layer of sub-freezing air, maybe in the lowest few hundred feet of the atmosphere, below freezing, including the surface below freezing. So you'll get the snowflake melting, and then a liquid raindrop will hit the surfaces but freeze on contact, creating a sheet of ice. And this is the ice that you see that covers everything. It covers the power lines, trees, road surfaces. It can make things very hazardous out there. So, and then of course on the right you just have rain. If it just snowflake just melts into liquid rain. So. Let's see. Is there any questions on precipitation types? Okay, I don't see any questions at this time, so. I forgot to mention too, there's graupel is another precipitation type, and that just occurs when snowflakes kind of bump into raindrops. The raindrops turn the snowflake into like partially melted balls or snow pellets, and this is different from hail and sleet because it's just kind of partially melted, refrozen snow. So that can happen sometimes too, especially in lake effect. So another thing that we watch out for, and this is very important, and we appreciate as new Skywarn spotters definitely getting reports from you guys on this, is what we call snow squalls. And snow squalls have been proven to be especially hazardous in our area. They can produce significant vehicle accidents and things along that line. So, you know, the definition of a snow squall is an intense but limited duration period of heavy snow accompanied by strong gusty winds, maybe even lightning, and it oftentimes will kind of refreeze on the roads into a sheet of ice as well. Watch out for that. Snow accumulations can be significant, but again, it's pretty short duration. So now we have a new product that we issue called snow squall warnings. We've been issuing these for about the past 2 to 3 years here in New York and northeastern Pennsylvania. And again, we decided this was a product that we needed to issue, a warning that we needed to issue because these snow squalls didn't really fit into our definition of winter storm warnings or lake effect snow warnings. These are different. These are like small lines of heavy snow moving through the area. They could maybe only last 15 to 30 minutes at one location, put down a quick 1 to 2, 1 to 3 inches of snow, but the visibility will drop to near zero with those gusty winds, and the roads will freeze over into ice sometimes. So it can be very dangerous. And you can see the reason why, because we issued these is because we've had, according to statistics, number of fatalities due to weather events. It's actually the highest of winter-related motor vehicle accidents. So these can potentially kill more people every year, even more than tornadoes, heat, hurricanes, floods, etc. So very important that we issue these warnings. And I think they are helping the public stay safe out there. Here's an example of one that we issued back in February 2018. It just has your kind of standard warning format. We give the time it's valid for. So it was valid for 1 hour from 10 a.m. to 11 a.m. on this day. We indicate where the snow squall is located and where it's moving. So it's moving southeast at 30 miles per hour. The hazard, heavy snow. We had the source from radar and webcams that was showing the snow squall. And the impacts was dangerous, life-threatening travel. So, and then we give some precautionary statements at the bottom, what you can do to help keep yourself safe. So, but really the thing is that we say that there really is no safe place on the highway in a snow squall. So our goal is to get these snow squall warnings out with enough lead time so people can make the decision to stay off the road for the next 30 minutes or next hour, because we have this dangerous snow squall coming through and it's really not safe to be out there. So, because like I mentioned before, the visibility can go down to literally zero. Like you won't be able to see even a few feet in front of you. And in that situation, even pulling off the side of the road on the highway can be dangerous because other vehicles may be drifting off the road and could hit into you. So again, if you see a snow squall warning, you just really want to probably stay off the roads if you can, if possible. And we also give an indication. These are available through Twitter. If you follow us on Twitter, where we show the area that's underneath the warning. So indicated by the red shaded area. So again, we talked about snow squall safety a little bit. The main thing is if you can stay off the roads when the snow squall is coming through, that's the most favorable outcome, is just stay where you're at, stay off the road, wait. It could possibly move out. Excuse me, it could be moving out of the area within 30 minutes. So if you just wait 30 minutes, the conditions can be a lot better. But if you're already out on the road or you have to travel during a snow squall, just do the best you can, leave extra time, travel slower, turn on your headlights. Obviously, don't slam on your brakes. Just try to stay as safe as you can out there. But again, as the first bullet says, I would really consider avoiding or delaying travel until the snow squall passes. So these are the situations where we see those multi-vehicle pileups on the highways when you have just a significantly reduced visibility near zero and comes on possibly unexpectedly if people aren't receiving these warnings, or in the past they were not receiving these warnings. So that's where we have these accidents, and that's what we're trying to help mitigate, help avoid by issuing these warnings. So again, for you guys as newly trained Skywarn spotters, this is something that we would definitely love to hear from you on. Give us a call, tweet at us, put it on Facebook. We'll talk about the different ways you can reach us later on, but just let us know the conditions out there. And you know, sometimes our radar doesn't work great as you get further away, especially on with these snow squalls, because they're so low in elevation. So your reports would be critical. If you let us know, hey, we're seeing near zero visibility, gusty winds, heavy snow, just got 2 inches of snow in 15, 30 minutes. If you call us and let us know, that would help us a lot to issue the warning downstream. So, any questions on snow squalls before we move on? Okay, I don't see any questions. Trying to unmute all of you guys in case you have a question, but I'm not sure if it's letting me. Excuse me. If you can't, for some reason, verbally say your question, I think I unmuted everybody, but if not, just type the question in the chat or the question box if you can. So I don't see any questions right now. So, oh wait, got a new question. Hang on. Oops. Okay, let's see. So from Corey, he says, will the presentation be made available through our email after the training? Yes, we'll send out a copy of the training for sure to everybody so you can review it and I'll have it on hand. So thank you for that question, Corey. Yes, we will make it available for sure. Okay, I don't see any other questions. There we go. Okay, no, with no other questions, we'll move on then. Okay, so the next thing we're going to go over is how to properly measure the snowfall. Believe it or not, measuring snowfall can be a difficult task to do consistently and efficiently with different people and different ways of training. So this part's definitely important. Snow measurement takes a little bit more time compared to measuring rainfall. But accurate and timely snowfall measurements can be extremely important to our National Weather Service, to ourselves. And we use public works departments, media outlets, and Skywarn spotters like yourself to help collect these snowfall reports. So we'll get into it here. So most of the time we are concerned with newly fallen snow or the storm total snow from an event. We're going to go over where, what, and how to best measure, best measurement practices, how you can send in the snowfall reports, and we'll talk briefly about other observations such as ice accumulation, flooding, etc. So the first thing you need to do when measuring snow is select a good location. The best location is going to vary depending on your location and topography of your property, whoever you're measuring. But things to keep in mind, the best site will be, you want relatively open ground, protected but away from buildings or tall trees. You want to minimize drifting as much as possible. But honestly, not all sites will be perfect. Just do the best you can. Let's see. So do the best you can. Sometimes you might have to average. You can go take different measurements, like 5 or 6 measurements, and average them out in an event that you're getting a lot of drifting, so that can help. But let's take a look at some of the common mistakes that we see. So here's an example. If you're measuring directly underneath a tree, a lot of that snow is going to be being caught by the tree, won't make it to the ground. So notice here, he's only measuring 3 inches of snow underneath the tree. Now, if he moves to an open area, this is going to be a much more accurate measurement of what actually fell. And this is getting 6.5 inches. So yeah, big difference. You don't want to measure under a tree. It's important to keep that in mind. So, what you can use to measure, we got different tools. You can use a ruler, measuring tape, or yardstick. We'd like to get your reports to the nearest 1/10 of an inch. I mean, you can use fractions of an inch, but I think if you can round to the nearest 1/10, that's good. If you say we got 3.25 inches of snow, we're going to put that in our system as 3.25, which is going to round up to 3.3, for example. So try to go to the nearest 1/10 if you can. Okay, yeah, I already mentioned this, but if you're having problems with drifting snow and the wind, you can take an average of measurements. So go around, pick spots where you don't see a lot of drifting, and just go ahead and take like 5, 6 measurements or more, however many you can get, and then average them together to get a more accurate measurement in that situation. So let's see. Yeah, this is kind of the example of the average I was talking about. So you got your old snow on the bottom here. You don't want to use that. You don't want to measure on the left-hand side. There's a big drift, maybe could be near a building or a snow fence or something out there is causing a big drift. So don't use that. But you can take 3 different measurements. You got 6.3, 4.1, 5.2 on top. Again, don't measure the old snow. You're measuring only the new snow. Then you just average them together, and that would be your most accurate measurement. So that's one way to do it. To take 3 or more measurements. So what can you measure on? You can measure on the grass or an elevated surface such as a deck, that's fine. I would just be careful with the grass. You don't want to push down too much into the grass and make that part of your measurement. Just try to go just to the top, so you're not including that extra measurement from the grass, obviously. So a deck is usually good, but just be careful. A back deck, the snow, if it's windy, the snow could definitely blow off the roof and kind of swirl around and create drifts on the deck, so just be careful of that. Again, you can measure a few different locations to get an average. It's always helpful. We definitely recommend measuring on a snowboard if possible, if you can get one of those. That's the best thing to do. So. So here's an example of a snowboard. If you are using a snowboard, it's a good idea to mark the location of your snowboard with a flag, reflector, or stick, because once you get 2 or 3 inches of snow, you're never going to find your snowboard underneath the snow. So you definitely need to mark it. Well, I would say some of the best objects, if you don't have a snowboard, again, just try to measure away from the building, because you could have drifting or snow coming off the roof affecting your measurement. So if you have like a picnic table out in the middle of your yard or something, that could be away from the trees, that could be a good place to measure. Even measuring on top of a car can be good if that's away from wind effects. So different locations, just try to use your best judgment. Don't take the highest drift, don't take the lowest area. Try to take an average of what seems to be the most consistent newly fallen snow. And the best thing would be to possibly get a snowboard. And a snowboard could be anything, just a piece of plastic if you have it, or maybe like a piece of plywood painted white. That can work too. So snowboard's best, but just do the best you can if you don't have a snowboard. So other than snow, we are definitely interested in ice accumulation as well. And really, we're interested in any ice accumulation. So even if you have freezing drizzle just coming down very lightly, that can be dangerous on the roads, and we need to know about that so we can issue winter weather advisories, etc., to keep everybody safe out there. So yeah, just even if you're just measuring, just saying I got a light coating of ice, a trace of ice, or but if you start to get thicker ice, if we start to get like a real solid freezing rain event coming in, you can definitely give us ice measurements as well. Those are more difficult to do, but do the best you can. You can measure on a tree branch perhaps, or chip away some ice off of a flat surface and measure the thickness that way. But ice thicknesses, we generally do it to like the nearest, I would say probably the nearest like 1/8 of an inch. If you can do it with a ruler, would be good for the ice accumulation. So you could have 1/8 of an inch, quarter, 3/8, 1/2 an inch, and 1/2 of an inch of ice starts to get very significant. And that's where we issue our ice storm warnings. If you see more than 1/2 an inch of ice accumulation, we're talking about the solid freezing rain accumulation. So if you see that, if you get more than 1/2 an inch, that's where you start to see tree branches starting to break, perhaps power lines starting to break, and you get into some real big issues with that. So other than that, we also are always looking for ice cover spotters for the rivers and streams and creeks across the area. If you'd like to do that, you can provide ice reports online once per week. This helps us to determine the thickness and coverage of the ice, again, on the rivers, streams, and creeks, so we can assess the possibility for ice jams if it were to break up. So if you're interested in that, definitely contact our hydrologist here. There's his emails, james.brewster@noaa.gov for more information. And again, we'll be sending out this presentation after we're done here, so you guys will have his contact information. We could always use more river ice spotters for sure. Okay, so now we're going to talk about some of our products here that we issue at the Weather Service. And this is really important to keep in mind that we have different tiers of impact level. So the highest impact level is going to be a warning. So that'd be our winter storm warning, lake effect snow warnings, ice storm warnings, or high wind warnings, or flood warnings in the wintertime. And that just means that the hazardous weather event is occurring, imminent, or very likely. A warning also means that the conditions pose a direct threat to life or property, and if you're in the path of the storm, you need to take protective action immediately. A watch is a little different. It's used when the risk of a hazardous weather event has increased significantly, but the actual occurrence, location, and timing is still a little bit uncertain. So a watch means that hazardous weather is possible. You should have a plan of action in case it gets upgraded to a warning or becomes more imminent. So when you're in the watch phase, you want to just pay more attention to our forecast, keep up to date with the latest weather updates from media, wherever you get your updates from. Just be aware that hazardous weather could be moving into the area within the next day or two. So, and then the advisory is when an event is occurring, imminent, or likely. So similar to a warning, but it's less serious conditions compared to a warning. So that could be, it can still cause a significant inconvenience. And if you're not careful, don't use caution, it could still lead to situations that may threaten life or property. But the main takeaway is that the advisory is a less serious condition than a warning. So the warning is the most serious. You have hazardous weather imminent, occurring right now, or very likely in the near future. Then you have the advisory, which is the event is occurring, very likely to occur in the near future, but it's a little bit less serious than the warning. But still, if you're under an advisory, winter weather advisory, anything like that, you still want to use caution to avoid any situations that could threaten your life or property. So. And then the least serious one is going to be the outlook. We do the hazardous weather outlook, and we issue this when confidence is still kind of low, but there is at least some potential for a potentially significant weather event coming up, usually in the 3 to 5 day time range. So, do I have any questions on this before we move on? Okay, we have a question on, this is from Daniel, and he's asking, not about exactly this, but he was asking about the timeliness of measuring snowfall. Does snow compact over time? Yes, very good question, Dan. Appreciate that. That's a good point. Yes, we ask that you try to get out there and measure the snow as soon as you possibly can to when the event ends, because the snow will compact over time, and that can have an impact. A lot of people measure snow. If you're an observer, you can maybe measure at between 7 to 8 a.m. every day. That's fine too. But again, the snow will compact. So if the snow stopped at 11 p.m. the night before, there will be some compaction if you don't measure until 7 or 8 a.m. But we understand you can't always be there to measure the snow at 24/7. So just do the best you can. But yes, the most ideal thing would be to get out there and measure as soon as the event ends. So, good question. Thank you, Daniel. Don't see any other questions right now, so get back to this. So now we'll just move on a little bit here and talk about our website and where you can get the different weather forecasting and warning products. So hopefully you guys all know, but if not, you can access the weather service at weather.gov online. And if you click on our area, it'll take you to our homepage here at the weather service in Binghamton. So this is weather.gov/BGM will take you directly here. The link. So this is our homepage again, and I guess some key things to look at. On top, you're going to see the news headlines here. Those are just some links of what we have going on. Let's see. Then the main thing is going to be the map here in the middle that will show any of the hazards, the current hazards, highlighted in different colors as well. It's, again, going to show the watches, warnings, advisories, outlooks on this map. And if you click on your location here on the map, that'll give you the forecast along with any warnings or watches that are in effect. Or in this window on the upper left, you can enter your town, city, location, or zip code and get a forecast that way. And then below the map, we have a bunch of different links here to really anything that you can want weather-wise. You've got radar, current weather, information on rivers and lakes, satellite, forecast maps, hourly forecast. You got your winter weather tab, which will be especially interested for us tonight. And there's a lot more if you click that. And then you got the weather hazard briefing, enhanced hazardous weather outlook here, our forecasters discussion, which I highly recommend as Skywarn spotters if you have time to read our forecast discussions. That really can give some insight into what we're thinking as meteorologists here at the Weather Service. Then another link that will be of interest to us tonight is going to be submit your storm report. We'll talk more about that. You got your text bulletin link where you can pull up any of our latest text products, climate information, Skywarn tab, obviously be of interest to us tonight as well. No weather radio, fire weather, air quality, sunrise, sunset. So a lot of information on our webpage, pretty much anything you could ever want weather-wise. So we'll take a closer look at these coming up. Yeah. So if you click the winter weather tab, this is what you're going to get. It takes you to our snowfall forecast images. And so what we do is recently we've been giving kind of like a range of outcomes so that people understand that there can be a range and we don't know exactly how much snow is going to fall with every system. So in the middle, we have the most likely official National Weather Service forecast for snowfall. This is just an example from last year. But you can see, you know, we have a different shading of colors. If you look at your certain location, your town, for example, if you look at Rome, we're expecting 4 to 6 inches of snow. Syracuse 3 to 4, Binghamton 3 to 4, Elmira 1 to 2, Wilkes-Barre 1 to 2, etc. So that's our official National Weather Service forecast. But then, again, we acknowledge that there is uncertainty and that these amounts could vary depending on exactly how the storm plays out and our confidence level. So if you look on the left-hand side, you got your minimum, or we expect at least this much. So your minimum, at least somewhat likely scenario. So there's a 10% chance that in Syracuse you only get 2 inches of snow. Binghamton you get less than an inch. There's a 10% chance that you get no snow in Wilkes-Barre. But then on the other end of the spectrum, you have your highest, your maximum or potential for this much snow, where if the storm trends stronger, more snowfall, more moisture, you could see higher amounts. So if this scenario played out, Rome could see 12 inches of snow, Syracuse 12 inches, Binghamton 9 inches, etc. So we kind of give the range of scenarios on this page so that everybody understands that there's some uncertainty. And this will vary. Sometimes if we have a lot of confidence, all three of these will be very close together. There won't be a lot of change between the minimum, most likely the maximum. But in this example scenario, there was quite a bit of range. I mean, it could range from less than an inch at Binghamton all the way up to 9 inches of snow at Binghamton. So this kind of gives you an idea of the uncertainty as well in the forecast. Also on our winter tab, you have the exceedance graphics as well. And these can be very useful if you have certain thresholds you're looking for. So if you need to get out and shovel or snowplow, if you're going to get more than 2 inches of snow, this will give you a percentage chance that you're going to get more than 2 inches, more than 6 inches, 12 inches, all the way up to more than 18. So definitely could be useful. Let's see. I think I'm going to go ahead. We do have snow tonight, so I'll go ahead and actually get out of the PowerPoint for a second here, and I'll show you guys a real-time example of these graphics. So again, we just go to weather.gov/BGM. This is what we talked about. We got our map here in the middle showing we have a lake effect snow warning in effect right now for northern Oneida County. So you want to scroll down to the winter weather tab. Click on that. So since we have a current warning in effect, that will pop up your current hazard, but we're going to go to the probabilistic snowfall. And this is what we just talked about here. So we have the expected amount, which is our official forecast. So we got 5 inches at Boonville forecasted, 2 inches at Rome, 3 at Hamilton, less than an inch for Syracuse. And then we have our low end, or what we can reasonably expect with the lowest amount possible. So we could just see an inch or so at Boonville and Hamilton. And then you have your higher end amount. So 10% chance to see more like 6 inches and 8 to 12 inches up just north of Camden up there. So this again just kind of gives you the range. And then if you scroll down, these were the exceedance graphs we were talking about. So if you're interested, hey, what's the chance we get more than an inch of snow tonight in Cortland? Okay, there's about a 35% chance we get more than an inch. What about in Boonville? 86% chance. Very low chance at Syracuse tonight. 0, basically 0. So same thing, Binghamton. So, and maybe you want to know, hey, I need to maybe go do some plowing or shoveling up. I'm in Hamilton. Okay, well, there's a pretty good chance, more than 50% chance of more than 2 inches. So again, I think these are very useful for the upcoming winter. So, okay. Go back to the PowerPoint. There we go. Okay, let's see. Do we have any questions on any of this so far? Okay, don't see any more questions in the question tab. We'll continue on. I guess I could have showed you this on the last page too, but this is more just like a graphical, or not a graphical. This is more like the percentages, more like a text kind of chart type of way instead of looking at the visual map. So again, this would give you different percentages of getting more than an inch of snow at Binghamton, or more than 4 inches at Hamilton, etc. So this could be very helpful as well. Okay, now if you click on the weather hazard tab here, this will bring us to our briefings. And in fact, I'll go back on our website. We can show this in real time too. Maybe it's just easier to go through here. So we'll stick with the PowerPoint. But yeah, our briefings, we issue hazardous weather briefings anytime we have, well, for the minor events, we do 1 slide graphics. And if we have a more significant event with winter storm warnings or significant winds and snow combined, or even flooding combined too, we'll do a full PDF briefing, which will be available again on this tab, the hazardous weather briefing tab. Just click on that. You can view all of our slides, all the information you may need should generally be on there. If we have a significant historic event coming up, we will do webinars with our partners and with the public, just to keep everybody better informed. So, okay, then we also have the enhanced hazardous weather outlook. Yeah, I'll show you guys this one online. Go back to our homepage. So again, this is where you get the briefing, the red tab, but we have the graphical hazards as well. This is the enhanced hazardous weather outlook, and this is just a quick, easy way to see what kind of hazards are coming up over the next 5 days or so. So you can see on the chart on the right here that these buttons will highlight different colors or different impact level. So right now we have snow and sleet is lighting up orange, and that's indicating elevated threat for snow and sleet potential across the higher elevations of central New York, northern Oneida County, and even some red significant impact expected across the far northern parts of Oneida, where they're under that lake effect snow warning up there. And if you scroll down to the more towards the bottom of the page, they'll let you know what this means. So for snow and sleet, the elevated range is going to be 3 to 6 inches of snow, significant 6 to 15 inches of snow, etc. So got that. We got winds also looking gusty. So we got shows you where you could have potential impacts from winds, possibly even some lightning, some thunders up here tonight as well with that heavy lake effect coming down. So yeah, I think this is a great product to look at too. Hopefully you guys will take a look and it'll be helpful to see what's coming up in the next 5 to 7 days as far as hazardous weather. Okay, back to the PowerPoint. So talk about that. Okay. And then this, we're going to go through how you can submit storm reports, which this is very important. As new Skywarn spotters, you definitely will hopefully have a chance to submit a storm report to us. So yeah, you want to click on this button here again on our homepage. It's the green button that says submit storm report. And once you do that, you'll get this page will pop up. This shows you all the different ways, 5 different ways in order to submit a report to us here at the Weather Service. You can report via email to bgm.stormreport@noaa.gov. We are on Facebook and Twitter. Those are excellent ways. We monitor that 24/7 as well. So feel free to submit a report over social media. Just be sure to include your location and that you're a trained storm spotter. You do that. Or you can, number 4, you can use this web-based mobile form, which we'll talk more about. Or you can call us on the spotter hotline, 1-888-603-1402. We're again always available 24/7 every day of the year. So we will be here if you call us on that number. Let's see. So we'll skip over this for now. Most of it, if you take the spring Skywarn spotter talk, we'll talk more about severe weather aspects and what to report. But for the winter, we're going to be looking for reports for heavy snow, icing, flooding, or heavy rain. So that's when you submit a report. Or the snow. We talked about the snow squalls as well. That would be a good thing to report. Basically anything that you think is significant or out of the ordinary weather-wise. We'd love to hear about it. So when you click on that submit report number 4, it's going to take you through this to this page here. You want to use the drop-down menu, select Snowfall, for example. Then you can put in your time, the amount of snow. Did you estimate, measure? Or just add some details, so you can include all that. It will show you what you're going to be sending to us. If it looks good, you just hit the send report button and you're good to go. So very easy. Hopefully it shouldn't take you that long, just a few minutes to submit these reports to us. And again, very helpful. We need to know the ground truth, how much snow is falling, what's the snowfall rates, are you seeing strong winds, or are you seeing drifting snow, blowing snow, anything, are you seeing icing? This is all really important for us to know here at the Weather Service. We appreciate any of these reports. Okay, moving on a little bit here. If you're not at a PC and you want to still access our weather information, you can always access it on your mobile device at mobile.weather.gov. And it's pretty similar. Still gives a detailed forecast, links to our radar, satellite forecast discussion. All that good stuff is on there. So I highly encourage everybody to test this out on their cell phones or mobile devices. Let's see. There's a link right on there to tweet a weather report as well. So that could be good. Let's see. Yeah, all the information's there. A few things are missing, like we don't have the winter weather tab to look at the snowfall maps on here. You have to go to our main website for that. Another good way to stay up to date with the most current weather is going to be using your no weather radio or the voice of the weather service. So hopefully everybody has a no weather radio at home. If not, it could be a good idea to get one. And these are great because they, all they do is you can play the weather information. So if that's what you're looking to get, you can get it'll play through our forecast, our watches, warnings, advisories, climate information goes on there, the hazardous weather outlook, the current conditions. You can get all that, and it's really good for like short fuse warnings in the summertime as well for severe thunderstorms coming in, or tornadoes, or flash flooding. I just think it's a good idea to have a radio on hand if possible. So, of course, you can get information, like I mentioned already, we're on Facebook and Twitter. So we'll be putting, I wouldn't rely on this 100%. Definitely still check our webpage, still have the weather radio, still check with your media outlets, but we do usually put our weather briefings and snowfall maps and that type of thing on our Facebook and Twitter. So that could be a good idea to also follow us on there. And as mentioned before, this is a good way to submit your snowfall reports or other hazardous weather reports right to us via social media platforms. So definitely, if you're not already following us, I would go ahead and recommend that you do so on Facebook and or Twitter. So, okay, now we are going to talk about some winter safety real quick. Let's see if we have any questions before we move on. Okay, I don't see any questions. We'll wait another minute and see if there's any questions on what we just covered on the website, and different products, or where you can get the information, how to submit a storm report. Okay, I don't see any more questions, so we'll move on then. Okay, again, moving on to winter safety. So this is very important to keep in mind as we head into the winter season here. So if you're heading out, traveling on the roadways during winter weather, some of the things you want to do just before you head out, check the National Weather Service forecast. Make sure you're not heading out into a snowstorm, ice storm, anything like that. Check the winds. Just want to check the conditions. Then you can go to the DOT websites, check the latest road conditions as well. Make sure there's nothing hazardous out there as far as that goes. We mentioned putting mobile.weather.gov onto your mobile devices to help you stay alert when you're out there on the road. Maybe if you have a passenger, they can check the latest weather updates while you're driving, that type of thing. You want to make sure you winterize your vehicle, make sure it's ready for the upcoming season. I think we all know how to do that pretty well. Make sure you have the proper windshield wiper fluid in there. Make sure it's going to hold up to the cold conditions. Make sure you have proper tires for the snow and all that kind of good stuff. So make sure you have a snow brush. Well, that kind of goes along with the pack an emergency supply kit. Just make sure you have maybe a snow shovel, snow brush. Yeah, here's more. This is pretty much everything you could want in your winter supply kit. So, I think I do have most of this stuff in my vehicle. You just want to be prepared. You don't want to get stranded, stuck out there in dangerous winter weather without having some of these things on hand that can really help you get out of a bad situation. So we just like to remind everybody to stay safe out there and try to have these winter survival preparedness kits in your vehicle. Let's see. Yeah, I mean, some of these things can potentially save your life if you get stranded in a significant lake effect or blizzard out there. You want to have extra pairs of hats, gloves, mittens, stay warm, some water and food, and keep your cell phone and charger so you can possibly get in contact with somebody, hopefully, to help you out, and a snow shovel. I think is really useful too. So in case you have to dig yourself out. So just be prepared. But the main thing to do is check the weather forecast before, make sure you know what you're getting into. Let's see. Yeah, I mean, as we get into winter here in central New York, northeastern Pennsylvania, it's going to get a lot colder. It does every year. Could get a lot colder at some point in time. You could see temperatures go below 0. We even see down to -10, -15, -20 during some winters, especially up in New York. So yeah, it can get really cold if you're stuck outside or in your vehicle and you didn't prepare properly. These are some of the warning signs of hypothermia, which obviously you want to avoid. But if you're seeing some of these signs, or if you're seeing these signs in somebody that you're outside with, whether you're skiing or walking, hiking, or you're stranded in a vehicle, if you see these signs in somebody else, this is when it's time to possibly call 911 and get some help. So confusion, shivering, difficulty speaking, getting tired, stiff muscles, that can all be signs of hypothermia. So watch out for that. Okay, let's see. Okay, it looks like we have about 10 minutes left here for the last section. Don't see any other questions. Let me check again real quick if anybody has questions on the last section there. Okay, don't see anything. So we'll just move on and we're going to talk about some bonus coverage here of the winter outlook for this upcoming season, what we could possibly expect. So could be interesting to some of you guys. So what we're looking at, we kind of took a look at the ocean temperatures, which can be a big key player into what we can see in the winter here. And it looks like we're seeing a weak to moderate La Nina develop. So that just means you can see the area of colder water right along the equator out in the eastern central Pacific Ocean. So that indicates that the La Nina is developing out there. And we have a warmer pool of water north of Hawaii, which is interesting too. And we have warmer than usual water off the Atlantic coast as well. So this could all play into what we see here in the winter. But the main factor is probably going to be the La Nina developing, and all the extended range models are showing that La Nina continuing through the winter months. So pretty good confidence we're going to see that La Nina. And what we did is we went back and looked at some of the historical weather data. We went back and looked at previous weak to moderate La Nina years and saw what actually happened if you combine those seasons, those years on a month-by-month basis. What kind of temperatures and precipitation anomalies did we see? So looking back at November from during those La Nina years of the past, putting the analog years together, really November was right near average temperatures, and precipitation was pretty close to average, maybe a quarter inch more precipitation than average over the eastern part of the area. So this November possibly could be the same, but we're into November now, so we're starting off cold, and it looks like it's going to warm up a lot actually into the 60s by the middle end of the week into the weekend. So we have quite a nice warm stretch of weather, and then probably dip back down. But overall, it's probably going to be near to slightly above average, I'd say, for November this year. And then looking further ahead to December, again, based off these analog years, what we saw in La Ninas of the past, December actually trended colder. So we could be in for a rather cold December with slightly above average precipitation too. So I'd say we could definitely see some potentially decent snow events in December coming up, with temperatures between 2 to 3 degrees below average for the month possible. So December looks wintry. And then January actually trended back to just near average temperatures, near average precipitation. But it's important to keep in mind that January near average temperatures are cold. So it's going to be probably a cold January as well. Average temperatures in January are like lows in the teens and highs around 30 to 32 or 35 in the area. So pretty chilly. Definitely still see some snowfall in January. And then February was again near average temperatures, possibly a little bit above average. So it's pretty close to average. And it got wetter, more precipitation in February. So with average temperatures, that could even mean more snow in February too. So we'll have to wait and see on that. And then there was a strong signal in these previous La Nina years for a rather cold March coming up. So it looks like it could be a cold one to end the winter, with 2 to 3 degrees below average temperatures for March and near average precipitation, which can lead to some significant snowfalls in March as well. So putting it all together for the winter as a whole, you want to look at November through March, basically near average temperatures, maybe a degree below average, but very close to average, I would say. Precipitation, very close to average as well, maybe a half inch above average for that whole period. So we're basically expecting a very typical winter with several snow events and ice events and generally near average temperatures. So not expecting a very warm winter, not expecting a super cold winter, just somewhere right around average. And we went back and looked at these La Nina winters for snowfall as well on a monthly basis here. So you can see this is for Binghamton at the airport. And when comparing it to average, these previous La Nina winters had higher than average snowfall indicated by the green squares in November, December, and March. They had lower than average snowfall in January, excuse me, and near average snowfall for February. So whether or not that will happen this year, that remains to be seen, but this is just some of the trends that happened in previous La Nina winters. So we'll have to see what happens here. Sorry, looking at this. Yeah, so again, a lot of indications are for possibly snowy December, so we'll keep a close eye on that. And then just kind of near to below average for January, February, and a strong finish. So overall, for the higher elevations of central New York, like up at the Binghamton Airport, we're at 1,600 feet. Indications are we could be near to slightly above average snowfall for the upcoming winter. And then for Syracuse, looking further north in the lake effect area, they kind of just got off to a decent start in November, December with above average snow. And actually, there was a really strong signal for below average snowfall in January for the lake effect areas, such as Syracuse in January. So we'll have to watch that. And then getting back on track close to average snow for February, and a strong finish in March, again, with a strong key signal across the area. So Syracuse, averaging these La Nina winters together, ended up right near average snowfall, 125 inches for them. But you can see there was variability, so we just don't know. I mean, could we be in the lower end? Could we see 97 inches of snow? Yeah. Could we be on the higher end, 157 in 1971? These were all La Nina winters. So really the range of outcomes is pretty wide, but overall near average. And then looking down into northeastern Pennsylvania, around the Scranton, Wilkes-Barre, Avoca area, they got off to, looks like they generally got off to a decent start in November with snowfall, around 5 inches for the average in these La Nina winters, but there was potential. A few years had basically none, trace 0.1, 1 inch of snow. So we'll have to see how this November plays out. Again, it looks warm for the next, after we get past Tuesday or tomorrow into Wednesday, it looks warm for the next 7 to 10 days after that. So we'll see. And then December, which is near average, January near average. February was actually lower snowfall in northeastern Pennsylvania. And then again, stronger signal for above average snowfall in March. So averaging out to right around the normal snowfall for them as well. So overall, I think we could just say it looks like a pretty average winter coming up. Snowfall, temperature, precipitation wise, but I'm sure there will be local maximum and minima of snowfall throughout the year. So, and again, we just showed this. This is the average annual snowfall map. So, wherever you are located, I would say expect pretty close to this for this winter, but we'll see. You know, we have a long winter ahead. So we'll take a look at kind of the official temperature outlooks here. And from NOAA, they're leaning a little warmer than what the analogs were showing. So there's potential it could end up a little on the warmer side. We'll see. But November, December, January, they're giving us like a 40% chance of above average temperatures. Could just be slightly above average. So precipitation near average. And then December, January, February, very slightly tilting towards maybe slightly above average with a 33 to 40% chance of seeing above average temperatures. But again, it could just be like a half a degree or a degree above average. So I'm thinking pretty close to average, and no precipitation near average as well is what they're forecasting. And then the second half of winter, you can see it's trending just a little cooler, but they still have us tilting towards maybe just above average on that temperature. And precipitation trending a little wetter, but pretty close to average too. So main takeaway is near average temperatures, precipitation, and snowfall for the winter. Not seeing a strong signal either way for a very warm winter or a very cold winter. But we'll have to see what happens. So things can change. So I think we kind of already went through a lot of this. Just a real quick wrap up. So here we are in November. We're already seeing a few accumulating snow events, and I wouldn't be surprised to see another one towards the end of the month, towards Thanksgiving as well. But overall, the theme remains near average temperatures, precipitation. December trending a little colder potentially, if current thinking holds. And several snow events seem likely, at least advisory level or higher for northeastern Pennsylvania, 2 to 4 advisory level or higher events for central New York. And then January is actually trending towards below average snowfall based on those analog years, except perhaps northeastern Pennsylvania. We'll have to see about that. And just kind of expecting 1 to 4 advisory level or higher events for the area. February returns to near average temperatures, maybe a little bit above average precipitation, and just kind of the same theme, couple of snow events each month expected. And then March, as we mentioned before, really turns the corner, potentially gets a lot colder, 2 to 4 degrees below average with near average precipitation. But that's, if you're that cold in March, it's going to be a good chance for above average snowfall. So we'll probably see a few rather significant snow events in March as well, but not much out of the ordinary, really typical winter. So that's what we're looking at for the winter outlook. Okay, we're really wrapping it up here. This is just a reminder of all the different ways. And again, we'll be sending this presentation out to everybody that attended. So this will just be a good page to look at to see different methods on how you can send those reports into us. So we talked about social media, got all these methods here for you guys. This is a reminder. And that is it. So thank you so much for coming. I hope everybody learned something today about winter weather and the winter outlook and what we can expect coming up this year. You know, hopefully we all know how to measure snow better now, and we all know what watches, warnings, advisories, hazardous weather outlooks mean. We all know where to access the different products we issue at the Weather Service here. So those are the main takeaway points, and we're happy to have you guys now as trained Skywarn spotters. Really appreciate it. Look forward to talking to you guys on the phone or seeing you on social media or email, sending in those reports. Again, it's crucial to us here at the Weather Service that we know what's going on the ground at your location. So that's it. We'll wrap it up here. This is just our contact information the people that are in charge of the Skywarn program here at the office, if you have questions or anything. But that is pretty much it. So at this point, I'll open it up to any additional questions and see what we have from there. So any questions at this time? Okay, thank you very much, Kelly. Appreciate that. Kelly just said thank you, and it was a great webinar. So thank you. Appreciate that. Any other questions from anybody? Okay, I'll wait another minute or so if there's anybody thinks of any questions. Otherwise, everybody else is free to drop off. And again, really appreciate you guys volunteering to be our Skywarn spotters. So thank you again, everybody, for joining in. Okay, I don't see any questions. If you have any questions, probably best to type it into the question box. I'm having some problems hearing you guys over the computer here, so. All right, well, I don't see any other questions. So again, thank you, and I'll be signing off. So thanks, everybody.